So the forces that make up the Newton's third law pair have some of the following characteristics. The most important one, they are equal in magnitude, opposite in direction. Now, a very confusing case is when an object is placed on the surface of a table. So, for this one, we're going to draw a table, and on top of the table, we have placed a box. So, this is a situation when an object is placed on the surface of the table. Now, let us draw the forces that would be acting in this situation. So one of the force would be vertically downward, which is known as weight of the box. So this is the weight of the box. The table also has a box, but right now we're mentioning the forces that are acting on the table, acting on the box. Then there is a force that is vertically upward in this case, and this force is known as the normal contact force. It starts from the contact point, which is here at the table, at the surface of the table. So it starts all the way over here. This is a point of application of this force. So this is the normal contact, and the weight is vertically downward. Now the confusing thing is, if the system is in equilibrium, then these two forces would be equal. So for example, if the weight is, let's say, 5 Newton, then the normal contact has to be 5 Newton as well. Now these two forces are equal and opposite, and we might be tempted to say that these two forces are the pair of action and reaction forces. But the thing is, these two forces, W and R, the normal contact, are not the pair, are not the action and reaction pair. These two forces are not action and reaction. So what are the reasons for that? Okay, these forces are of equal magnitude. We can put a check mark over here. The two forces are opposite in direction. We can put a check mark over here. But the problem is in this part. These two forces are not of the same type. Weight is a gravitational force, and the normal contact force is a contact force. A gravitational force is a non-contact force. Even if you throw something in the air, if we have a ball over here, we throw the ball in the air, the weight is still acting on it. But the contact force would be there only when this ball is in contact with the surface. So these two forces are not of the same type. Secondly, these two forces are not acting on different objects. The weight is of the box, so it's acting on the box. The weight is basically the force in this case, the weight of the box means the force that the earth exerts on the box. That is the weight of the box. And the normal contact is also being exerted on the box. So they are not exerted on different objects. They act along same line. Okay, yeah, that could be it. But if any one of these property or characteristic is not being fulfilled, the forces cannot form the pair of action and reaction forces. Now, so if weight is considered as a force, then what would be the reaction force of weight? The weight of the man is basically the gravitational force which the earth is exerting on the man. And at the same time, the man is also exerting the same force, equal force on the earth. But the thing is, the Earth doesn't feel that force much because the mass of the Earth is too large to compare with the mass of the person. But with respect to the weight, the gravitational force, the reaction force to that is the gravitational force that the man exerts on the Earth. Likewise, we have a contact force in this case. So, contact force that the Earth exerts on the man, which is upward, and there is a contact force which the man exerts on the Earth. So, these two would form a pair of action reaction, and likewise, these two, this one and this one, would form a pair of action reaction forces. So, the reaction force, this weight is the force that the earth exerts on the block towards itself. That is the force W, weight. So W, let's call it small w. Force the earth exerts on the box. Now the reaction force to that is not the normal contact force, rather it is a force that the block would exert on the earth towards itself. Let's call it capital W. So capital W, or you can go with W1, W2. So capital W is the force the block exerts or the box exerts on the earth. Now, what kind of forces are these? Both of them are gravitational force. Okay, you can also go with W1, W2 if you want to call it this way, W1, W2. So W1 is the force that earth exerts on the block or on the box, and W2 is the force that in reaction the block exerts on the earth. The earth doesn't feel it because the mass of the earth is too large for that force to make any significant effect. And that's why we feel that the box is moving towards the earth, not the earth moving towards the box. If the box and the earth were of the same size, if box and the earth, let's say this is the earth here and this is a box, if they were of the same size and you throw one of them upward, then both of them would be moving towards each other at the same rate. But the thing is, the size comparison is totally is or I should say not even comparable for the box and the earth. Now if this is the, let's call this one as the action force, then what should be the reaction force to this one, to the normal contact? So if action force is normal contact, the reaction force should be of the same kind. The reaction force should also be a force which should be a contact force. It cannot be a gravitational force. So if this is the force that the table exerts on box when they are in contact, then the reaction force to that one should be the force that the box exerts on the table when they are in contact. So let me draw it over here. Let me call it R2. So I can call this one R1. So R1 is the table, the force table exerts on the box, and R2 is the force that box exerts on the table. These two would be equal, these two would be opposite, these two would be acting on two different bodies, these two have the same type, so these two form action and reaction. And likewise, W1 and W2, they would form action and reaction. Now, once again, what kind of questions do you get from this one? They don't ask for the definition, rather, you get these kind of questions from this topic. So, here we have the first one. As you can see on the screen. So, we have to answer for what pair of action and reaction. What is the action? One of the forces of this pair is the weight of the box, which is represented by W. Which arrow represents the other pair of the other force in this pair? Now, anyone who would like to answer this with the explanation? Action force is weight. What is the reaction force? Is it A? Is it C? Is it D? Okay, so you're right, absolutely right about it. It is A. But let me ask you the other question. Why not B? B is also opposite. Yeah, exactly. These two, if we take a look at these two, W, it's a gravitational force, which is a non contact force. And the other one, B, that's a contact force. So these two are not of the same type. They cannot form pair of action and reaction. They are not of the same type. Likewise, if we talk about W, so W is a force that the earth exerts on the block, and A is the force, as I explained previously, that the block exerts on the earth. So action is A, or you can say action is W, and reaction to that one would be A. And both of these forces are of the same type. And what type of force that is? Gravitational. And if B is the force, that is the force that the earth exerts on the block when the block is in contact, then C could be the force that the block exerts on the earth when the block is in contact. So B and C could form a pair. But they asked us about which one forms the pair of action and reaction forces with W. The answer is A. Let's take a look at another question. So anyone who want to answer this one, and this one is easier. It's even easier. No, no, just this one. Just couple of questions only. We have this MCQ and then there's another MCQ. That's it. Yeah, anyone who can answer this one. B, the second one. Yes, it is indeed B. And could you walk us through why B is the right answer? Why do you think B is the right answer? Exactly. And these two forces are of the same type, right? Both of them are gravitational force. So in the option D, you see weight it's a gravitational force, but the lift is not a gravitational force. That is force due to the engine. So this one is gravitational, the other one is not. What about option C? The first one is gravitational and the other one is not. The other one is not a gravitational force. What about the option A? The two forces are equal. They may or may not be equal. If the driving force is 10 Newton, can the air resistance not be 5 Newton when the object is accelerating? In that case, the driving force could be greater than the total resistive forces. So they won't form a pair of action and reaction. Also, the other thing is, in the option A, the driving force and the air resistance, both of the forces are acting on the same body. Matter of fact, the two forces should be acting on different bodies. What about the option D? Same problem with it. The weight and the lift, they're acting on the same body. Likewise, in the option C, they're acting on the same body. But it is only the option B in which the forces are acting on different bodies. Type wise, first of all, resistive forces are contact forces. Resistive forces are contact force. The driving force itself is not a contact force. The resistive force would be there only if there is contact with something. The air is in contact with the vehicle, then we have the air resistance. If there is no air, then there is no resistive forces. So these are not even the same type. The driving force is the force produced by the engine. Resistive force is not the force that is produced by the engine in any way. So that's it, everyone. Up next, we are starting.